Now we move from smart contracts to the application layer, where real systems connect to Fabric. You'll see how SDKs, the gateway, identities, APIs, and events work together to submit transactions securely and handle results reliably. So far, we've built the Fabric foundation: architecture, transactions, confidentiality, chain code, data models, endorsement, and access control. This section shifts that foundation into practice, focusing on the applications that invoke contracts securely through SDKs and gateway APIs. Client applications are the business-facing entry point to Fabric. A user action, such as creating an asset or approving a shipment, becomes a chaincode function call. The application uses an SDK or gateway API, along with the user's identity, to submit that request. Fabric Gateway coordinates the proposal, endorsement, ordering, commit, and result flow, so blockchain complexity stays behind backend services while users see reliable business outcomes. Think of evaluate as asking the ledger a question. The application sends a query, receives the current state or a computed result, and nothing is ordered or committed. Reads stay fast because they avoid unnecessary network work. Submit is for something different: a proposed state change that requires endorsement, ordering, validation, and commit. The application design rule is simple: evaluate for reads, submit only when the ledger must change. A transaction begins when the application builds a proposal with the chaincode name, function, arguments, and caller identity. From there, the gateway handles the network-facing work. It uses discovery and endorsement policy rules to choose suitable endorsing peers, gather the required endorsements, and submit the endorsed transaction for ordering. After blocks are delivered and peers commit, the application receives an outcome it can act on: success, commit status, or a handleable error. From the application's point of view, endorsement is not about tracking every peer. It is about satisfying the policy for this transaction. The gateway can discover eligible endorsers and request the approvals needed, such as signatures from both org1 and org2. If access, chaincode execution, peer availability, or policy matching fails, the transaction cannot move forward. Strong applications turn those technical failures into clear business messages the user can act on. Submitting a transaction only starts the finality process. The ordering service sequences the transaction and packages it into a block, but it does not decide whether the transaction is valid. That decision happens when peers check endorsements, version conflicts, and access rules. The result is commit status: valid and committed, or invalid and rejected. When business outcomes matter, applications should wait for this confirmation before treating the transaction as final. Once a transaction commits, Fabric can publish block, transaction, and chaincode events. Client applications subscribe through event listeners, then route those signals to databases, indexes, notifications, or business workflows. Because events are asynchronous, the application must be resilient. Store checkpoints, reconnect cleanly, replay from the last processed block, and make handlers idempotent. That way, missed or duplicate events do not corrupt downstream systems. Every action a Fabric application submits is tied to an identity from an organization's MSP. That identity usually combines an X509 certificate, which says who you are, with a private key, which proves it cryptographically. SDKs and gateway clients load these identities from a secure wallet, and the MSP determines whether the certificate is trusted. The identity you choose affects permissions, endorsement eligibility, and auditability, so private keys must never be exposed, copied casually, or logged. Before an application can submit transactions for a participant, that participant needs a trusted identity. The usual flow starts with registration, followed by enrollment with the certificate authority, which issues cryptographic credentials. Those credentials are stored in a wallet, where applications can import, find, update, delete, and back them up. From there, roles and attributes define what each identity can do. In enterprise environments, this should connect to IAM or SSO, approval workflows, and least privilege. Private keys are production-grade secrets, not configuration files. Store them in protected systems such as HSMs, cloud KMS, vaults, or encrypted key stores. Then plan for change. Certificates and keys should rotate on a defined schedule, and applications must tolerate identity updates without long outages. If an identity is compromised or expires, revoke it through the CA and MSP processes. Finally, monitor usage patterns so suspicious signing activity is detected early. Treat the API layer as the controlled doorway into Fabric, not just a convenience wrapper. Front-end clients should call REST, GraphQL, or a backend for front-end service, while the server side handles identity, validation, authorization, rate limits, and logging. This layer can orchestrate Fabric transactions, combine ledger results with enterprise data, and hide SDK complexity. The result is cleaner client code, stronger security, and an architecture that fits normal enterprise operations. These integration patterns are complementary, not competing. REST works well for direct commands and simple queries, such as creating an asset, transferring an asset, or updating status. GraphQL helps when the user experience needs one tailored view assembled from ledger records, off-chain databases, and profile data. Event streams handle what happens after the transaction: notifications, analytics, replication, and workflow triggers. A typical Fabric design uses REST or GraphQL for interaction, and events for scalable downstream processing. In production, failures are not exceptional, they are expected. Retry network or peer availability issues, but never blindly resubmit a transaction that may already have committed. Use transaction IDs, request IDs, and business keys to recognize duplicates. If a commit times out, query status or reconcile state before trying again. The safest design is idempotent. Repeating the same request produces the same business result without double spending, double shipping, or corrupting ledger state. You now have the application-side foundation for Fabric, using SDKs and gateway flows to evaluate, submit, endorse, commit, and react to events. Just as important are secure identities, clean API abstractions, and resilient integration logic. Next, we extend this into advanced event processing and enterprise connectivity.